this particular research, what we are trying to do is to predict this elastic property for the model and the simulation.
In this work, what we did, I think it's quite helpful to the community of simulation because these days, the nanoscales, very extreme small scale simulation is very important for nanotechnology. They are trying to make groundbreaking things, but it's really difficult for experimenting because of the outreach of current technology or experiment. So what we did, actually the only approach now available, I think it's the simulation, like for example, molecular dynamics, what we used here. But for this kind of simulation, the model, the key part is how are you going to model the interactions between the atoms. So that's really the key. If you can provide an accurate interaction model between them, then the result should be accurate. But the thing is, there are so many choices in the literature field. So what we did is trying to shorten people's time to make appropriate choice of those interaction functions. And then probably, I hope we can then provide help them to find the most reliable results in their simulation. And this is the benefit of this, I think, the most important impact.
Simulations on nanoscale is getting much more widespread these days. And atomistic simulations, such as molecular dynamic simulations, are valuable tools for simulating the different properties of nanomaterials or advanced materials like nanobeams and nanolayers, or different applications which are newly being found in different areas of science or engineering. For having an accurate molecular dynamic simulation or any atomistic simulation like a Monte Carlo or other atomistic simulations, we need to have a force field, which or they are known as interatomic potentials, which are modeling the interaction between atoms. And there are different models in the literature review of these potentials, and each of those has been designed for any specific application or problem. But among multiple interatomic potentials, it is so important to know which one is accurate or appropriate for our problem.
So for this nano device, the properties, because it is key, right? The property is the key, and whether the potential or the interactive potential is accurate will determine the accuracy of the simulation. And this kind we call the numerical experiment because it's kind of real stuff, but cannot be done through experiment because, as I said, the technology, the state-of-the-art technology is really not that level.
If anybody tries to start researching this area,
Exactly.
they go to literature, they found there are over 100 different potentials. Then which one is good, which one is not good? So basically what we're trying to do is that when after our research, people will know, oh, for this particular case, I should use this, not that, so that we save people's time.